So, I admit that I lied last time that I talked to you, and I lied with one crucial respect with this ice core. And that is that way down here in the bottom, things are very badly messed up, and we can actually not tell the dates like we can in tree rings by counting back. We can actually only do that for Greenland, and only for the last 10,000 years. How do we get the date for going back 400,000 years? We cannot get it in any easy way. This is a very, very tough problem. So we've got it for 10,000 years, but going beyond that is a big problem. I'm going to suggest one idea. Well, let me just go ahead. What is happening in these areas? We've got high temperature, but we also have a high sea level. How can we use that? High sea level. Well, what we could do is we could go out and we could find ocean creatures that grow and see if we can find any of those at these two levels. So this is what we're after. We're after coral. Coral incorporates about 3 parts per million of uranium as it's growing. Just a very small amount of uranium. Okay? So here we have a coral, and we have it taking uranium and absorbing it, and it's part of what they do. Now, this is a very different uranium. This is uranium-234. Remember, there's 234 of these little things in the middle of the uranium. That's a very different uranium than uranium-235. Uranium-235 is the creator of nuclear bombs. We're not going to go there. Uranium-234, that's where we're at. Uranium-234 is not stable. Every 245,000 years, half of, if I had a whole bunch of uranium-234 here, if I waited like this for 245,000 years, half of it would be gone. So, there we go. Boom! It's gone. Did you see that? I was kind of excited. I want to do that again. There we go. Okay, there's 234. I'd have to wait 245,000 years to see that happen with a single piece of uranium with the probability of happening. But anyway, I have to do it again. I just enjoyed it so much. Okay. So we have here a coral, and of course this isn't the real size of uranium-234. It's really, really small. So I've just blown it up here for your benefit. What we're going to do is we're going to see what happens in 245,000 years. Here we go. Oh, we've just lost half of them. Another 245,000 years. Oh, we've just lost another half of them. Another 245,000 years. We've just lost another half of them. So you can imagine that we can use that information to find the age of that coral. So here we have, we found this coral pretty high up. Okay, so it's at a pretty high sea level. We found this coral. So let's check how much of it there is left compared to the amount that it started with. Remember, we know how much it started with because uranium is absorbed by 3%, 3 parts per million. Okay, so let's see. Well, there's actually 70% of the uranium there that we would expect if we find a fresh sample. So if I got this old sample, it's got 70% compared to this new sample. So what does that mean about age? That means that we are at 125,000 years old. Okay, for that coral. We also find corals that have a little bit less. They've got 51%. And so that ends up to be 237,000 years old. So we can take those two numbers, and we have two numbers on our graph. We've got 125,000 here. We assume that this is from this peak, and 237 here, and we assume that that's from that peak. What do you think the error is? What's the probability that I got this right? Well, pretty low. Actually, nobody uses this exact technique. I kind of made this up. But it's based on real techniques that are used with uranium and coral. But this would have a lot of error associated with it. So I say 237,000 years. That could be, 300,000 years, it could be 200,000 years. Really a lot of variability with this technique. But other techniques are better than this one. This is just an easy one to describe. Okay. You notice the periodic peaks in this diagram. So now what we're going to do is we're going to go back, and now we're going to look 5 million years. Before we were looking 400,000 years in the future. Now we're looking 5 million years in the future. And again, we see these little peaks, and they keep on going. Actually, those peaks continue, and there's two different periods. The peaks here, they last about 100,000 years each. So each jump here is about 100,000 years. The peaks over here, about 41,000 years. So what's going on? Why these sudden peaks? Well, James Croll, between 1821 and 1890, he was a janitor in a school, in a museum, and he had no education beyond age 13, and he came up with the idea that this was due to the patterns in the Earth's orbit. So, for example, the axial tilt. You probably know right now that the Earth is at 23.5 degrees tilt, but that is all the time changing. Okay, here we go, all the time changing. It changes from about 24.5 to down to about 22. And guess what? The period of that changes over 41,000 years. You go back and forth. So, a good option for those quick little oscillations that we see in temperature on the planet. And this is pretty well established now. This is where we are here, 23.5 axial tilt. Another change that we can get is where June happens. Is the Earth close to the Sun or far from the Sun in June? The Earth doesn't go around the Sun in a circle, as you all know. Instead, it goes around in an ellipse. So, if June is far from the Sun, then that's one option. But we could also have that June is near to the Sun whenever there's sun. Okay. And this has a periodicity of 21,000 years. So that's not one of our major ones. We didn't see that number coming up before. Nevertheless, it does contribute, and if you look at the data more closely, you'll see that that number does come in. Another change is the eccentricity of the orbit. So it goes from being more circular to being more eccentric, and that changes on 100,000 years. So this is astronomical events explain both of these periodicities, and this is well established now. Okay, and for the next time step, I'm going to move to 24. I'm going to increase that to 34 because we need a little bit more space here. Okay, here we go. This is the temperature over the last 60 million years, and I'm going to end tonight's talk with just going through some fun slides, just looking at North America over those 60 million years. So you see, we go back and forth between, in the early times, between glaciers and non-glaciers. This is 135,000 years ago, 3 million years ago. Notice that Hudson's Bay is no longer there. 8 million years ago, you notice that the ice cap on Greenland has totally melted. 15 million, 50 million. Notice that Florida is now submerged. By this time, there's no ice caps on either Antarctic or Greenland. 60 million years ago and 65 million years ago. Thank you very much. I will see you tomorrow.